I already failed math.
You feel mad, wow. Why?
Wow.
How is that possible?
Yeah,
I rushed. I was spending 20 minutes on one question.
Oh,
And it was only question 5.
No
and I only
wonder,
had
no
45
wonder
minutes.
maths fail, right? How can you spend 20 minutes?
Because I was like, how do I do this question? How do I do this question? How do I do this question?
You know you don't have enough time, right? Hard to say. Hi, Blossom.
That's not true. There's several factors.
Okay, wait, let me find the set one size.
Like remember last year how I didn't do my paper two and I lost
His story about how he was accused of cheating. But now he's a thing. I used to be 60 years old.
You were accused of cheating then?
Yeah, man, I couldn't do anything because I was very mad.
You were just what?
I was mad.
You were mad.
I'm angry. People kept on accusing me for cheating.
Is it real or not real?
Which is not real.
Oh. But you were allowed to continue to do it.
Yeah. But I was mad, so I couldn't do anything. I couldn't think.
For the PSLE. Wait, so you feel like one of
I
the
passed. I still passed. Even though I only did
right. Okay, separation technique.
If you finish the paper, I think you'll get like that.
Yeah, give me a minute. That's fine. Separation. Okay. Worksheet 1 for solution suspension. 4.2. Where's my 4.2?
It's gone.
Yeah.
Oh, you're on the correct one now.
So you can sign another one. Sorry, Blossom, give me a minute. I'm finding the worksheet. I'm doing the separation technique again. Saturday. Oh, yeah, 4.2. Do you have access to this, Blossom? The separation of mixtures worksheet 4.2.
No.
Blossom. Can you hear me? Blossom, can you hear me? I'm doing this worksheet 4.2. Wherever you go. Hi, Blossom. I think you can hear me. Blossom, can you hear me?
Yeah.
Oh, okay. Can you find the worksheet 4.2? It's the separation of mixtures.
Where's the
Yes, please sign.
Online.
No? Okay. Can you see the question? If not, never mind. You can just refer to the screen. Okay. You can see the screen, right? The one that we're sharing. Okay. All right. So we're going to go through. Yeah. Thanks. We're going to go through this. Okay. This separation technique, okay, is under mixture. So when it comes to here, we need to know what is the meaning of mixture. What's the definition of mixture? Let's ask Jim.
Trust me. Trust me.
No, why? Never mind. Jim, what's the definition of mixture?
A mixture the substance that is a mixture the substance that is made up of two or more substances Not like chemical means.
They are not chemically combined. Okay. So as long as they are not chemically combined, they can be separated by they can be separated by separation technique. Now the name given to this separation technique is physical. We call this physical separation. It's not chemical separation. Okay, so these are also known as physical methods of separation. Right. So what's the difference between physical method and chemical method? Chemical method usually involves electricity or involves the use of chemicals, right? So something changes, the chemical component changes. But when we separate using physical method, is there any chemical stuff involved? No, right? So you're just separating something that can actually be separated. That's just physically separating them. So what are the separation methods that you learn? We actually go through a few of them, okay? We went through them already. We went through like filtration, we went through evaporation, we went through distillation, we went through paper chromatography, right? We did not go through reverse osmosis, and in primary school you went through.
I went through reverse osmosis.
Oh, that's great.
Same.
Yeah. So in primary school, you already went through magnetic attraction. So these are the few separation methods that you need to know. Okay. So before we go into that, you need to know that these methods, right, are not only used during your theory exam. Okay. Next time in Sec 3, Sec 4, you know you're gonna have practical exam. You know that, right? Science lab, right? Science lab, right? So you go to the science lab, you have to go to science lab because the O levels, one of the requirement of O level. Yeah. So, but now you don't have the practical exam, like your SA1, SA2 don't have practical, but good for you, right? So when you go to O levels, there's actually a paper. I think it's like paper 4 or something. Yeah, you need to go to the lab and then they will give you instructions. So sometimes the instructions will be separation techniques. Okay. Yeah, you can do. They may ask you to do crystallization. They may ask you to do filtration. They may ask you to do chromatography or distillation or whatever it is. Okay. So you need to know. You know this not just for theory but the practical as well. So now we're going to explain what are the different types of physical methods or separation technique. Basically what we want to know is what is the theory behind how these can separate stuff. Okay, so for example, magnetic attraction. Okay, now the reason why magnetic attraction works is because some materials, some materials are what? There are some magnetic material, okay, and then there are non-magnetic material. So what are examples of magnetic material? So magnetic material contains iron, cobalt, nickel, okay, or their alloys like steel. So once something is magnetic, you can use a magnet to separate them. Now, where usually do you see this type of things being used? What? Junkyard, right? So junkyard magnetic separation. Okay, so yeah, did you see? Right, so they use this. Why do they do that? Because some of these metals could be recyclable, right? So they use magnets to remove these metals to be recycled. And after that, the rest, which is usually plastic or maybe even fabric or cloth, they are not useful and just thrown away, right? So that is magnetic attraction. So they use electromagnets, okay? So you can see this. This is an electromagnet. Okay, next one. Okay, next is a very common one, right? So this is the separation using filtration. So filtration, the setup is this. Now what this does is it separates the soluble from the insoluble. So there are some stuff that are insoluble, like for example, if you have a mixture of water and sand, so the sand will be left here, right? So this is a bit common sense. So water will pass through. So how come this works is because the sand particles are too big to pass through the filter paper. Yeah. So now, but what is important here is the keywords, okay? Usually they'll ask you like, what is the residue and what is the filtrate? So the filtrate is the stuff that passes through the filter paper. The residue is the one that remains in the filter funnel. Okay, it's pretty simple. Okay, so an example is water works like this. Water filtration system is in our, our treatment of water. Singapore. Okay. Yeah, the new water and all this, right? So part of this process, right, is this thing, where the raw water, you know where we buy water from? We buy from Malaysia, right? So we take this water from Malaysia. One of the process is this, where we will run the water through this sand, gravel and pebbles and all this, and you get cleaner water. So of course, this clear water is not immediately potable or drinkable, right? You need to still go through some other chemical treatment before you can drink the water. But that's what we do. Okay, so this is one of the process. So in this process, you will filter off the dirt and whatever big pieces of impurities, right, which is stuck over here. Okay, so those in NCC, NCC land or Scouts or maybe MPCC.
Just any uniform group.
No. Only those that do camping one, right? You may have to camping. Yeah, you may have to learn how to drink from river water. Okay, river water. So one of the things that you do when before you even start to drink from the river water is you need to do a filter. You need to make a filter, right? So yeah. So how to make a filter? Usually you will use your socks, okay? And then after that, you're gonna find rocks, you find sand, you find pebbles. Just throw everything in layers inside your socks, and then you pass river water through it. Yeah, no, but you'll be surprised, right? The water that comes out is actually pretty clean.
But then your socks are still dirty. Yeah, think about it. Yeah, how do you get the water to get out of the socks?
Huh? No, you have to do some kind of a filter system, okay? Using soap and I can't do it now. I don't have river water.
Then what do you do?
Yeah, something like that. Use saliva. Yeah, I really have. Army also have, right? Army also have. Filter for drinking. Let's see images. Yeah, look at it. See?
What's that?
Camping potable water, right? So just put like river water here, then she can drink some kind of a filter here, okay?
That's a machine.
No, it's not a machine. It's socks, right? You have to learn. I mean, that is not socks, of course, but I'm just saying you can use socks to put the rocks inside all this stuff. They don't have a picture here. It's socks, right?
You use a plastic bottle.
Yeah, you can use plastic water as well. Yeah. Because next time in the army, you don't have plastic bottle, right? You only have whatever you bring with you, and socks is one of them. See, so you take out socks, you go and fill it with pebbles and whatever stuff like this, and then you somehow pass the water through, and you can drink the water. But of course, we don't drink. We don't drink the water. Because no, this is just to teach you that if you are really desperate and then you're dying, then you're like, oh, I got no water to drink. You can do that. But usually, they will issue you these tablets. There's a tablet. Yeah, there's a tablet that you. What? What? Is it iodine tablet? I don't know what's the tablet to make river water drinkable. It's disgusting. It's not powder. It's some tablet. See? So the kind of tablet that potable alcohol, I don't know what stuff. So basically, you just put it inside the river water, and like magic, okay, you can drink the water after that.
Water pollution.
But it's disgusting, okay? I drank it before. It's like, bleh.
But taste on.
No.
Then what you see there?
It's like dirt, okay? It tastes like mud.
How do you know?
What the hell do you know? Just tastes like mud. No, it's
Even if you put a tablet.
yeah. After you put the tablet, the
How do you know it tastes like good?
because I drink before, right? So
I
you will.
drink mud also.
I didn't drink mud. It's
How do
just
you know the taste?
like
Yeah.
you smell mud, right?
You don't smell mud.
You know mud
Like you
smell.
sniff mud before.
I never sniffed mud, right? But it has that kind of feeling to it, okay? So anyway, next time you will know, right? This drinking the river water, but that will be your. Then really is iodine water, potable aqua iodine water purification. Yeah, it's iodine stuff. Okay, looks like iodine. So people actually you can actually drink it, but it's just disgusting. Next, so that's filtration. Okay, so other examples of filtration, the coffee filter. You'll see that in the. You'll see that where coffee shops, right? There, coffee filter. Okay, because people want the aroma and the chemicals, but they do not want the beans. Okay, so you gotta do filtration. Okay, see the car oil filter, car air filter, all this, right? Aircon filter also, right? That's how it works, right? So what is the idea? The idea is that there are some stuff that's too big to pass through. Simple as that. Okay, next is evaporation. So here's an example of evaporation, where in this situation you don't want the water, but you want the stuff. Yeah, it does.
It worked 4 times on me.
No. Did you have to pay for it?
No, like us, we didn't the monthly.
That is so good.
And then I went closer to look underneath.
Oh. All right. All right. So you want the solid, but you don't want the liquid. Okay. In this case, so you let it evaporate. So that's how we obtain our salt, right? Salt. What is that? Okay. Salt. Okay. See, this is salt. So you just let the water evaporate, and the salt will be left behind. That's how you get the salt from. Tons of salt, just like that. Okay, water is gone, but the salt is left behind. Right? So that's one way. Solar evaporation, yeah, it's the same picture here, right? Salt mine. Maybe we can find the same picture. Mine. No. Different. Whoa. Okay. So this salt mine example. Okay, next, so this is the part that gets a little bit difficult, okay? Is the process of distillation. Now, in the process of distillation, you're trying to obtain a pure liquid from a solution. So what happens here is that both the liquid are mixed together. Okay, you cannot let them evaporate, because if you let them evaporate, both will be gone. So what you do is you use this distillation process. So in this distillation process, there are a few things that I need to go through, okay? So in this example, they are distilling sea water. So what happens here is that you put sea water inside here, sea water into this place, okay? Water will come out, and then after that, the salt is left behind. But another example can be alcohol plus water. Example, your wine, okay? You can put wine inside here, or beer inside here, okay? So when you put wine or beer inside here, what will come to the conical flask and what's left behind, do you know? Let's say we talk about alcohol and water.
Water.
Which one will come here? Which one will come
Water.
here? Water come here.
Yes.
Wrong.
No.
Wrong.
Alcohol.
Alcohol comes here.
Who say water?
You.
Yeah, who say water?
So alcohol alcohol comes here, right? Why?
Because what you say?
What do you say?
Just
You say alcohol has a higher. Singapore is
alcohol has a
higher what?
boiling point and melting point.
No. Anyway, else? Have you all gone through separation technique?
No.
Yes.
Yeah.
No. Yes.
Yeah.
Rachel? Have you gone through? Then you should know already. Alright. So why does alcohol come here?
Density.
No. Why? Rachel, why? Why does alcohol come here? So water is here. Water will be left here. Why? Cause what? Because it's very. Yeah, I wish I can say that now. No. There's one property. No. Both are soluble. They dissolve in each other. Huh? Burberry? What? What? Bottom. Why? Why does alcohol come here? Water.
The boiling point of alcohol is lesser than the boiling point.
Yeah, BP, right? It's got to do with BP. What do you say? But which one? You say this one is higher. It's wrong. This one is lower. This one is lower. Water. All right. Okay. What's the boiling point of water? 100,000, right? What's the boiling point of alcohol? 78 degrees Celsius. So let me explain. So when you put alcohol and water inside here, right, into this thing, oops, it's stuck. Okay, put the thing inside here, and you start to heat it with imaginary fire. Okay, so when this thing starts to heat, of course the temperature go up, right? So that's why you need to put a thermometer here, because once it reaches 78 degrees Celsius, you don't want it to increase some more. How come? Because at 78 degrees Celsius, what will evaporate first? Is it alcohol or water? Alcohol. So alcohol becomes gas, right? So A for alcohol. So all the alcohol, gaseous alcohol will come out. Okay, at exactly 78 degrees Celsius. Okay, because they boil, so the alcohol from here will boil and come out. Okay, now the alcohol will pass through this little pipe. Yeah, right. Yeah. Okay. So when they pass through this pipe, they come into here. Now what happens? What happens is yeah, Sarah's favorite process. Yeah, condensation. Now that's why this thing is called a condenser. There's actually another name for it, right? It's called the light bait condenser.
I've seen it in the
Yeah, it's called the. I want somewhere there. Okay. Right. Yeah. So this thing is called the condenser. So what happens to this alcohol, the gaseous alcohol, when it passes through? Condensation means from gas to what? Gas to liquid. Okay. So you become a liquid inside this part. Right. So I'm going to put L. So A become L. Right. And then they will slowly drip, and you get your alcohol liquid over here. So as long as you maintain the temperature between 78 and 100, you will get alcohol here and water here, because the water doesn't boil, but the alcohol boils.
Yeah,
Get it? Right? So now there are a few criteria. Number one, you have to put a thermometer here, and the bulb of the thermometer has to be at the opening. Why? Why can't I dip the whole thing inside here?
you have to measure the temperature of
The gas. Yeah, the vapor. Vapor is correct, okay? So your bulb has to be at the opening. Because if you put the bulb all the way inside the liquid, it will not be accurate, okay? You do not know if it is at 78, or maybe it might have already reached 100. All right, we want the temperature of the vapor, okay? So the bulb has to be here. Now, another thing is usually we will put this porcelain chips inside. Why? Why must put porcelain chips? Spread out the heat, okay? Why must spread out the heat? So what's wrong with focusing on one spot?
I forgot. I don't understand what you're saying anymore.
No, my question is why must put porcelain chips, not potato chips, right?
Potato chip 我们要你看 more fried potato chip.
Why put porcelain chips?
会有超大。
超大, what are you talking about?
Porcelain chips help spread out the heat.
Yeah, the idea is spread out the heat, okay, but why must spread out the heat?
Because I'm not the focus from the
I know, you should focus on
I
it.
forgot already.
What's
I know why.
the bad thing? Why?
I go check Google first.
You can check.
Only one spot.
Okay, very close, right? Now, have you boiled water before?
Only because no, it's not
Yeah.
one spot. Yeah. One like reach 100 first.
Good. Yeah, so So the correct phrase is you want to have smooth boiling. Smooth boiling. What do you mean by smooth boiling? What do you mean by unsmooth boiling? So if you had boiled water before, that is unsmooth. And when you see unsmooth boiling, okay, what do you observe in unsmooth boiling? Water, yeah, bubbles and brew, you understand? The what? Don't you hear that? I hear that all the time because I boil water all the time. So I see the water is like, I don't know, that is like very vigorous flying everywhere. So can you imagine if the water is going like then some of the W accidentally fly inside here, you know what I mean? Yeah, then your reaction is your chemical, not chemical, your separation technique, your separation becomes polluted. Yeah, some of the water goes like it flies inside here. Okay, so that's not what you want. Okay, you want smooth boiling. Okay, you want the W to happily remain inside here. All right, you don't want them to be flying all over the place. But yeah, you don't want them to be flying all over the place. You just want them to be happily inside here. You want the A to go out like that. Okay. Right, that's why you put porcelain chips. If you cannot find porcelain chips, what can you do? Put a porcelain spoon.
What's a porcelain spoon?
It's a spoon made of porcelain.
What's porcelain?
What?
Porcelain.
Make myself porcelain.
Spoon. Yeah, what's in porcelain spoon? Yeah.
Oh,
That's what porcelain spoon.
it's expensive. No, you waste of money. It's $6.
No,
Yeah, you're gonna pay 19.
No, I don't know why that $1. I'll take the $1 one.
That's probably a China scam. There is 19
This
ones.
is a spoon.
NTUC $6.
Yeah, scam.
1, 2, 3, 4, 5, 6. Okay. So just put a porcelain spoon, right? So a long time ago when my grandma was still alive, she would put spoon inside. Okay, I was like, why you want to put spoon inside?
So to make it black, make it warm, never be touched.
I never understood, right? So after I go to secondary school, then she understands. She studies at one science.
Wow, so impressive.
No, she never studies at one science. She just throw one spoon inside. Okay, I don't know why. Right, just to prevent the water from flying over the place. That's all. Okay, even out the boiling. So another thing you need to take note is the water in, water out thing. In this condenser, there's 2 outlets. Yeah, I mean there's one inlet and then there's one outlet. Okay, so you see we have to cancel this. This is wrong. Okay, please cancel this. Right, water goes in from the bottom and water comes out from the top. Now this is a bit weird, but why? How come water must go in from the bottom and water come out from the top? You must connect a tube. Yeah, you must connect one tap. This one tube connected to tap water. Okay, so because it's so this whole thing in my whole secondary school 4 years, right? No, I had never seen like the real thing done before because it's so troublesome to do. So I've only seen it once. Okay, because you need to connect like water here, water come up here.
Did you set it up for us?
That's awesome. Okay, I only saw it like I think one.
You know he did. He put Coke inside.
Where? Here?
Yeah.
Here? Then water come out. Is it?
Yeah.
And Coke left behind. Yeah.
My school is too broke to make any experiment.
Yeah. So, but now the question is, how come cold water in here and then cold water out here?
Isn't it supposed to be like a Bunsen burner?
Yeah, I said invisible Bunsen burner. Okay, why water in here? Why not water in from the top and then water out here?
So that you can control the water.
Here also can control.
You can control like the amount of water that comes out. Because it's magic.
Both also can control.
No, you leave it on there.
That's actually why? Do you know why? Why water here? Let's ask. Wait for an answer. Actually, yeah. She haven't said anything yet. So do you know? You also don't know. Really? Do you know? Do you know? Any idea? It's okay. It's actually a very common. There's no science to it. Okay.
Exactly.
There's no
Yeah,
science.
that's why it's good. Next question.
But you need to know water go in here and then water come out here.
Okay, why not?
Why? Why cannot water come? If you put water here, it'll be very nice, right? Water will flow out due to gravity. Isn't that good? Why must against gravity? Why must do against gravity? Why not? Yeah, why not? Why not? Let's do everything opposite, okay? Yes, Rachel.
So then it's
What?
like opposite.
What? Whoa. Logic.
Yay. We love your answer, alright, but it's not correct. I don't understand what you say anyway.
Oh, but this time is correct.
How actually, you know?
Space got no gravity.
As you can see here, we reward very creative answers, okay?
Oh, creativity of what?
Yeah, creativity of what, okay, but not correct lah.
Wait, no, you don't tell us the answer until we get it correct.
For what? Wait, actually you might know because she don't want to say. Actually, you know.
She too shy.
Because you keep talking, I'm talking to her, you keep talking.
Okay, we all shut up.
Yeah, actually, you know.
That makes everyone more stressed.
No? No? Yes? No? Say what? What do you say?
Then something rise.
Something heat rises. Ah, okay. So her reason is heat rises. Oh, you're talking about the heat rising out from here, is it? Heat rising out from here. Okay, no. But good try. Okay, let's ask Blossom.
Let's ask Mr. Ting. Blossom didn't take a textbook and then forget
Blossom.
Yeah, let's just get the answer.
Blossom. Hey, y'all always think she has a textbook beside her.
Even if you go to school, get it.
Also, do you know why water go in here? Actually, textbook never explain why.
Oh no.
I don't think that's explain
Google
why.
it.
Okay, I have to Google. Do you know? Blossom, do you know?
Yeah.
Oh, she knows. Okay, why?
Why did Blossom know everything?
Blossom 一个洞，洞的 size。
Okay, never mind. Blossom, don't worry about that, right? They are just ignore them. Okay, what's the reason why water go in? Of course not. No, I'm trying to get an answer. I'm trying to get an answer. Come, Blossom.
Because like if water enters from the top, then after that it immediately flows down, right? Then it won't be able to like condense the liquid inside
What?
like that tube thing.
I don't understand. Can you say again? When water.
So like
Okay,
if water when water comes
say again.
the top, if water comes from the top, after that it just flows down like that, then it won't condense like the liquid inside the.
Oh, okay. Half correct. Okay, so let me explain. You will what? Say again? You spin? No.
Yes.
Okay. The logic is very simple. The condenser, the whole thing has to be filled with liquid water. The whole thing. So if you put water in from the top, right? Where will it flow? Okay, let me demonstrate to you using our high tech.
Just slow down and out.
Alright, so imagine you put water in, too much. If you put water in,
It's still too late.
what?
You still have to bend.
If water goes in like this, right? Where does it go? It goes to the bottom and then it will flow out. Just like that, right? So you see, you cannot fill the whole condenser. But if you put water in from the bottom,
That's not telling me but you can just water.
when you put water in from the,
control the amount of water inside.
yeah, you will feel like that first, and then after you will feel yeah, you feel like that. Then the water will come out here. Can you see that? Then the entire condenser is filled with water. That's all. Okay, there's no science to this. It's just we want to fill the whole tank, the whole condenser with tap water. That's all. Yay. You don't have to be impressed, right? It's just the reason why. Okay, can you understand? You understand? Understand already? Now you understand, huh? Control the volume, but not very specific, right? I can also say control the volume. No. All right, so what else? The other thing is sometimes in exams I ever see before they close the setup is like that. They'll put this thing inside and then after that they close this thing. Okay, so this type of setup is wrong. Why? You see the actual one is open, right? Can you see the actual one got no closure. No, some you have, okay, the correct setup is to leave it open. If you close this thing, and then after that you put the tube inside like that, it's not going to work. How come? It doesn't work. Why? It's because the air cannot escape. If air cannot escape, your liquid cannot go in. Yeah, simple enough. That's all. Okay, so simple stuff here. Yeah, P6, right? All right, so here we actually have some of the reasons here. See, condense. Okay, no, they didn't talk about that. So anyway, that's what this is for. Now, this is what we call simple distillation. There's actually a more advanced one. It's called what's it called? Fractional distillation. Fractional distillation. So what is fractional distillation? The difference between fractional and simple is that they have a bigger, longer tube. Okay, there's like a longer tube right here. That's all. Okay, that's all there is. There is another distillation known as fractional distillation. This is fractional distillation. This is called simple distillation. Yeah. So the difference is that in fractional distillation, there's an additional fractionating column added into this portion. Okay. Now, what is the purpose of this thing? Is to create more difficulty for the vapor to pass through. So when it is very difficult for the vapor to pass through, it's like a filter kind of thing, right? Whatever you get later on is going to be very, very pure.
Waste of time.
Yeah, you waste the time. You let the vapor take a long time.
I mean, it's a waste of time.
Yeah, you waste time. Yeah, I agree with you, right? You waste time. So
you waste your own time.
So the vapor will take a longer time to pass through. So whatever you get is confirmed pure. Okay, that's all. Okay, so don't because some people get scared. They look at this and say, I never studied this before, though. But it's actually the same thing. Okay, it's the same as distillation. It's just that here, there are more. It takes more time, longer time, right, for the vapor to pass through. Right. Okay, so this is distillation. Okay, reverse osmosis, I'm not going to talk about it. I didn't think there's a need to go through that.
Well, teacher,
Yeah. Okay, then let's talk about it. So, what is desalination? Is the removal of dissolved salts from seawater. So now you reverse. Why is it called reverse osmosis?
You reverse it.
Yeah, you reverse. Then what is osmosis?
I have no idea. Google.
Osmosis is making the water pass from higher concentration to lower concentration. So reverse osmosis basically is you want the water to pass from lower concentration to higher concentration. Okay, that's the reason. So in desalination, they use reverse osmosis, which is primarily how we get our new water. Yeah.
Osmosis is a process by which molecules of a solvent tends to pass through a
semi-permeable membrane. There you see. So osmosis usually is where water pass through from here to here, from right to left, right? But reverse osmosis will be like water from here go there, water from here go there. Then you leave the particles here. That's it. Okay, it's reverse osmosis. Right. So this funny looking thing, no idea what this is. desalination plant. Okay. Right. Okay. So this fractionating column, comes from the distillation. So yeah. Crude oil. Okay, so this is a fractionating column in crude oil. I'll show you the Jurong Island.
Oh, that one.
Yeah, in real life it looks like this. Okay, so if you go to, if you see those kind of a chemistry plants, chemical plants, right? Usually they have like super tall chimneys or super tall columns that looks like this. What are they? They are actually fractionating column. Fractionating column, which is something like your, the distillation, the fractional distillation column. Okay, but of course they are not in, they are in mega form. Why? Why do we need this? Because we want to separate crude oil into the different types of products. Okay, let me get a better picture. Okay. All right. Okay, so crude oil can be used to obtain many things. Like for example, bitumen, fuel, lubricating oil, diesel, petrol, and gas. Right. So the reason why you can do that is because all of them has got different boiling point. For example, petrol is 70, 120, 170, and so on and so forth. Okay, so it uses the same theory as the distillation to help you separate crude oil into different parts. So this is what we, Singapore, does for a living, in case you don't know. Singapore, how Singapore make money through this?
Scammery.
Scammery, it's not scammery, it's science. Okay, we have this thing in a part of Singapore called Jurong Island. So in case you don't know how it looks like, island, okay, is near. Okay, Jurong Island. This is Jurong Island. It is a big part of Singapore. See Singapore. This is the whole Singapore. Huh?
What's so small?
What is so small? This Singapore, Jurong Island is this big, you know?
I say the whole Singapore.
Why? I don't know. Right? See, Malaysia. This is Malaysia. so
You
this
make Singapore look so big for a moment.
This is Singapore, right? And Jurong Island. Can you see how big it is? How big is it? It's bigger than Sentosa, right? At least like 5 times the size of Sentosa.
It's 1/4 of us.
It's not 1/4. It's like
What is?
a big part.
1/8.
Maybe
1/16.
1 out of 20, right? 1 out of 20. So what happens here? Oil refinery. Okay, we take crude oil and then we do fractionating column, we get out all that stuff. And why do we put Jurong Island so near to this? You know what it is? This is called the Tuas megaport. Right? Tuas megaport. Why? Because after refinery, immediately they come here, then the oil tanker will bring them to the rest of the world. Okay? So that's what we do. Singapore, right? Yeah, here. Something, okay? So you can see they are all chemical stuff. Okay, this whole thing.
Why don't they make it in the middle of Singapore?
Tough. Because it's dangerous. Alright, let's go in and take a look. Oh, we can't. You see? We cannot even go in.
Because the person wasn't even allowed to go in.
Yeah. So this whole place is cordoned off through this gate. Okay, there's a gate right here. You have to
maybe you can enter.
go here. Okay. I've been inside here before. Yeah. Why? Because this whole place, right, is it's so dangerous. You need, the whole thing is full of chemical and flammable stuff. That means things can go wrong very quickly. Okay, the whole place. So they purposely created an island place, everything here. So why did I have to go there? Because it was during NS, right? I remember I had to come all the way to the end here. We take the car, I don't know if it's here or maybe somewhere here. Or maybe even here. I think it's here. Okay, we have to come all the way here. Okay, why? To guard the place. Okay, in case some terrorists decide to come here and throw one, all you need is just like one grenade. right, the whole place might just explode because the whole thing is connected, all the pipes, everything. Okay, and if this one explodes, that's it, right? This is like our livelihood for Singapore, right?
This is not water.
What? Water? No, oil. Here you depend on oil. Next. Okay, the next one is paper chromatography.
Oh,
Yep. So paper chromatography, we talked about this before, right? It is used to test for drugs.
I have the chromatography before.
It's just a few people.
Yeah.
Yeah, they call it.
Okay, so this is how it looks like, you know, when they test for drugs. Okay. Testing for drugs, right? Here's another one.
Yeah, I think like this.
Yeah, filter paper. So the principle at which this works is through the solubility of the solute in the solvent. So you need to have a solvent. The first thing is you need to have a solvent here, and then after that your solute, you put a dot here. What will happen is that the solvent will climb up the filter paper very quickly, and as it's traveling, it will dissolve the solute, and after that it will spread the solute out in a certain pattern. So if the pattern matches whatever pattern that you want to check with, that means that that sample will have whatever you want to check with. Okay, it's inside that. It's inside the sample. Right. So what you're separating then is the ink or the soluble solute. Right. So the principle at which it works is different solvents have different rate of solubility. Right. So what are the uses? Colorings. Usually, you need to check for this permitted colorings. You want to check different types of ink in forge checks. Right. Some people forge checks. You want to confirm the ink, medicine, urine, blood analysis, detecting the level of pesticides used by police to analyze paint, pigments, detecting the use of illegal drugs by athletes and sports competitors outside. Okay, so I think we talk about the Armstrong guy, right? Lance Armstrong. Okay, this guy. So he is a celebrated cyclist. That means he won, like, for the past 10 years, he's won so much competition. Okay, so it appeared that yeah, he took drugs, right? Towards the last few events, they realized that, hey, this fella has been eating drugs, right? So they didn't really check, until towards the last one, they realized, hey, they took his urine sample and found that, through this chromatography, his urine sample basically has got contents of drug inside, and eventually his title has been removed. Okay, right? So if you didn't take the drugs, you wouldn't have won. That's the thing. Doping downfall.
So why would they check his urine sample?
Because it's not fair for other people who never take the drug.
How do they know the drug?
I don't know. Maybe through some random check, okay, they decided to check. Then usually they never check him because he always wins, right? And then people assume that he's like, he's good, so he always wins. So how dare you go and check the fella, Then one day, someone is like, why don't we just check his sample? Okay, and they found that, hey, this guy has been consuming drugs, okay, throughout all his career, right? So that's terrible. I think until now they haven't figured out how he did it, because it's a lot. 712 is like 10 years. About 10 years. Okay, that he kept winning and nobody actually checked him. Okay, so they use this chromatography to check. Okay, reverse osmosis. I really don't want to go through this. I never see this one being tested so much, right? As a step 1 level. So this one, I'm just going to skip. Okay, so we're done. Okay, now we have some questions here.
I'm not doing.
You might find it familiar.
You've done this before, right?
seems like the. Actually, I have another one.
No, when we did it. Alright, let me find out.
We did it before.
Looks very
Time to search.
familiar.
Time to search.
But you don't have to take it out, right? No point searching for the thing, right? It doesn't matter. I want to go through this anyway. Okay. Hmm.
Yes. Shouldn't find out.
Yeah, I think we can just go through this anyway. Okay, so any questions for separation technique? Anyone?
No.
Any question? No? Everyone okay? Right?
It's cool.
What?
See, this is the first time you heard saying this.
Yeah.
Uh.
Okay, why don't we go through this together? All right, and then you just share with us your answer. Question number 1. Let's start from Sarah. Separating funnel. What is it useful to separate? Hmm? No. Okay, first, do you know what's the separating funnel?
B.
It's a separating funnel. Answer is D. Two immiscible liquid. Okay, immiscible means that the two liquid will not mix, okay, like oil and water. So when you put oil and water inside this separating funnel, oil will be at the top, right? Like maybe the blue color thing is at the top.
But then you have to wash it.
Yeah, correct. And the transparent thing is at the bottom. Then what you do is you slowly open and close this tap.
That's such a waste of time.
Yeah, you open and close the tap. You let the transparent part come out first before you close it. Okay. So this is called two immiscible liquid. Next one. Okay, which of the following is most suitable for measuring exactly 39.8 cm of acid? Okay. Burette.
No, let's do it. Let's do it.
D. Burette. Burette is correct.
Yes, I'm correct. Hey, what?
Okay, burette. This is burette. Okay. So burette is a very, very, very long column of glass. Super duper long.
So it's 87.
Right. So this thing, once again, it's a tag, but the reason why it's so long is because it's very accurate up to 1 decimal place. Okay.
Are you sure?
Yeah. It's accurate up to 1 decimal place. You will use it, right? In Sec 3, there's this process called titration. You will get to use this thing. Next one. Rachel, which one of the following may be condensed by using a water condenser? The distillation. Distillation.
It's also D.
You could.
Nothing that happened. Yes, customers over.
D. Okay. So, yep, D is correct. Okay. Why? Because water liquid condenser is water. What's water temperature? I mean, room temperature is about maybe 25 degrees Celsius. So at 25 degrees Celsius, this vapor is at 148. When it comes to contact at 35, it will become liquid, but it will not freeze, right? Because the melting point is 13. So 35 degrees Celsius is right in the middle of D, so it works. Next, which of the following can be used to separate the color dyes in black ink? Ashley? Yeah, chromatography. Very good. Next one, Davian.
What?
The technique of paper chromatography depends on what?
The difference in color. No, C.
No.
Solubility.
C, right. Solubility.
No, he did not.
The pigments have different solubility. Next one. Proteins. Okay, let's have Blossom. Can you see question number 6? So we have this chromatogram. The evidence, right? P1 and
P3.
Okay, so what we do is we look at this line. Okay, we got P1 and B3.
Next one, straight line.
This is D. What?
Wow.
Eh?
Sure, that's not straight.
Okay, I give you a straight line.
Straight.
Huh?
Wow. Very straight. Oh, you're missing a little bit of the 3D.
See?
That is not straight.
Straight line. Next. Sarah again. Sarah. 7. What's the answer? C. We can deduce that Y contain
Oh, wait.
Y.
Wait.
Why?
Huh?
Wait.
Easy.
There's no way here.
Why?
It's either A, B, C. B. Okay. So look at this. Y you have B and C, and then Y you have A and B. So answer is B. Very good. Okay. Nice. Next. Question 8. Game.
Wow.
Question 8, Jim.
Okay.
Okay. So, why are the chromatograms different? They use the same flower for the same plant. How come the picture are different?
D.
D, the two groups use different solvents. Yeah, very good. Okay. You look very tired, but you can still put the right answer. Question number 9.
Using the last of the brain power.
The last of his brain power.
I am the brain power.
You are the brain power. What do you mean? Rachel, next 9. What's this? Raffinose. This evidence suggests that dilute hydrochloric acid breaks raffinose down into what?
Is that drugs?
I don't know.
Yeah, it's drugs.
No, it's a sugar. A sugar, raffinose, was treated with dilute hydrochloric acid. The resulting solution Y together with some known sugar for reference to analyze. Basically, it's just look at the line, right? Like this, what does it have? Fructose. Then this one is glucose, and this one is galactose, right? C, glucose, maltose, no maltose, no maltose. We have fructose, glucose, only 2 sugar, glucose and mono. So A is wrong. Glucose, galactose, glucose, B lah, right? Answer is B. Okay, now this is about, do you know how to read the chromatogram? It's not about, do you know what's raffinose? No, it's all about the chromatogram. Next one. Yeah, next one, right? Okay, actually, question number 10. Wow. The final chromatograms are shown. What is substance X? So look at this again. PQ, QR, PQ, QR. Wait.
I can't see properly.
What? And actually, yes, what's the answer? I said what? B. Yes, must be Q. Okay, because Q appeared in both, right? So it's here and it's here, so it's in both. Next one. Okay, a solid is likely to be pure if it, David, you go through this many times. If it's pure, what is the characteristic of something that's pure?
It does not react. No.
Yep.
It is all crystalline.
Exist? No.
It's A.
What? Answer is D.
Yeah, correct.
It melts at an exact temperature. So a pure substance always either freezes or melts or boils at a fixed temperature. Okay, so correct. Next one, Blossom. Whoa. 12.
Jim is going high.
Sorry, what did you say? C. P may contain cyclohexane. Okay, so once again, the idea is about melting point, right? So we see that the melting point is 60. It is the same as cyclohexane, right? You don't even know what cyclohexane, doesn't matter, right? So this is 60 degrees Celsius. To check its isothermal is repeated using 1 part of P. They take P and mix with cyclohexane, and then the melting point became 50. All right, so basically they made it into a mixture. Okay, they mixed the thing, and the boiling point decreased to 50 degrees Celsius. So P may contain cyclohexane. P is a mixture, or P is pure cyclohexane, or P is not cyclohexane. The answer is D. Okay, because if P is cyclohexane, and then you mix with cyclohexane, and then you boil it, or you're going to melt the thing, it should have the same melting point. Okay, but here you have different melting point. So what happens is that you have different substances mixed together. Okay, it's not the same substance. The same substance would have the same boiling point or melting point. Okay, next one. Sarah. Liquid is likely to be pure if the liquid is pure. Huh? Evaporates completely, no? No. C. It boils at an exact temperature. Remember I said before, right? If something boils at a fixed temperature like water, right, it's pure. If water is not pure and you try to boil it, it will be like maybe 105 or 107 degrees Celsius. Okay, what's the answer again? 4. B. Which one of the following is not a chemically pure substance? B. Sand. Yeah. That's pretty easy. Sand is a mixture. Okay. Next one. Which one of the following is likely to be a pure compound? Rachel?
Do random things again.
Rachel? Pure, huh? B, yeah, B is correct. Now, why is this correct? Because of the temperature again, right? It melts at exactly 1 temperature. Simple as that, okay? The concept is very simple. Next. Condenser is used in distillation. The purpose of condenser is to, what's the purpose of condenser? Actually? The clue is in the word, you know? What is a condenser supposed to do?
Condense.
Condense, right? Condense means from what to what?
Okay, so easy answer one now.
Huh? Correct. Vapor to liquid.
Hey, why did you get all that?
Yours also easy one, look at it. Yours is the easiest.
Nah, I don't know what it is.
Where do the hot vapor and cooling water enter?
Somewhere.
Where? Cooling
Somewhere.
cooling water, okay? Not cooling vapor, right? Cooling water. Where does cooling water come from? R, yeah. So B lah. That's the only option.
This is the one that Jim drink every morning.
This one?
Cooling water.
Cooling water. Okay, so B is correct. Next one.
I think Jim died.
No, it's fine.
I'm sure you know
Okay, this is the same. I'm gonna skip this, right? We did this one already. This one is the same one. So the answer is just D. Okay, it's the same as previous one. Next one. Distillation involved 19 Blossom. What are the processes that?
B.
Yeah, B is correct. Evaporation and condensation. First you evaporate, then you condense. Next one, which of the following is best for removing mercury? Sarah? You had mercury mixed with alcohol.
Oh shit.
Mercury mixed with alcohol. What? Distillation. Yeah. It's fine. Okay, wait, do you want to get 5 minutes break?
Yeah.
Yeah, let's take a 5 minutes break.
Yeah.
James is dead. It's like, he's dead. Okay, let's take a 5 minutes. Doctor, 5 minutes toilet break. Okay? James needs to go to the toilet.
Wow, I don't need to.
Yeah,
I'm
take
not
a shot.
related.
What? Let's go.
No, I love MCQ.
Yeah, so you bully you. Do work now. Okay, do now. Everything's okay. Come on, question 31. The best method of separating carbon from sulfuric acid is?
Me?
Yeah, you.
What
What is it?
Bully Sarah.
No,
Yeah,
not
yeah,
bully.
not
No, bully.
No, Josh, you know how to bully her? Make her do all the questions.
Wait. Carbon from okay, so this one actually quite difficult, right? Because carbon, do you know, can carbon dissolve in this? Even I don't know. Can carbon dissolve in acid? Carbon does not dissolve in any acid. Okay, so carbon does not dissolve in any acid. So if carbon does not dissolve in any acid, you can separate it using filtration. So the answer is B. All right. So this is B. Next one, let's move on. Jane, your turn.
I thought was
No, yeah, so do you. Which one of the following is the best sequence of technique to obtain crystal? Filter, evaporate, warm, crystallize. Okay, read.
Okay.
Do you know how to do crystallization?
No.
Yeah.
It's not that.
Warm, filter, evaporate, crystallize. Evaporate, filter, evaporate, crystallize. Filter.
I mean, you did the job. I did the same.
Okay, warm, filter, evaporate. B.
Because you have to evaporate to halfway.
Yeah. Okay, so crystallization, basically you want to obtain crystals, right? So this is copper
This is
sulfate
exact
crystal.
extract.
Yeah, copper sulfate.
You know the school does not allow us to keep the crystal.
Why?
I
Okay, this is a copper sulfate
took
crystal.
back and small.
You usually you can keep it, right? So
I took back small.
in the experiment you will be getting this crystal. So if your experiment is not successful, you'll get like powder form.
Why do you buy crystal?
I don't know. But if it is very successful, you get like huge crystals like that. Okay, you can grow big blue copper sulfate crystals. So what you need to do is you need to have a saturated copper sulfate solution first. You need to mix. Then after that you warm the thing, and then after that you put it one side. You filter away all the water, and then you just let it cool down. Okay, you let it cool down. Eventually, the water will evaporate, and then you'll get this leftover. Sorry. Right, you get the crystal slab. So this is how you get the crystal out of the solution. Now, before I forget, next week no lesson.
Why?
It's Labor Day.
Really?
Yeah, 1st of May.
Let's
Right.
go.
That's our holiday. Saturday no lesson. Okay.
Friday also no lesson.
Friday you're not here.
Let's go on Friday.
I don't know. But Labor Day I think is
Oh yeah, let's go on Friday.
directly on Saturday, so we don't have lesson. Okay, because I forgot to tell the previous students. Right.
There's
Alright,
school on
moving on.
Friday, but there's no school on Monday.
Is it?
Yeah.
Okay. So over here don't have, so Saturday don't count. Okay, Blossom, you heard that, right?
Yay.
Woohoo!
Yeah, okay. Okay, moving on. Which one? 23. Which one of the following processes should be used to test whether a solution containing a salt is saturated? How to test whether something is saturated, Rachel? Saturated means you cannot dissolve anymore. The point of saturation means you cannot dissolve any more stuff inside. Do you heat the thing? Do you stir the thing? Do you filter or do you add? Right? Okay. Okay, oh, sorry. Imagine your Milo. You keep putting powder, right? And then you're like, you stir the thing, and then you think to yourself, can I put some more? Is it saturated already?
Why was it
Can I put some more?
Yeah, hello. Someone fasting.
Huh? You stir to check whether you can put some more. No, the answer is put some more, right? So the answer is D. Okay, if it is saturated, the crystal will not dissolve anymore, right? It's the same with your Milo powder. If the drink is already saturated, you put some more, right? You become Milo dinosaur. Yeah, you be Milo dinosaur, right? You cannot saturate it anymore. Okay, next, which one of the following can be separated by adding water, stirring, and filter? Ashley? Add water, stir, filter.
Yeah, what is 5 minutes slow? I mean, we slow. Yeah, what?
Fast or slow? Slower. This one is slow.
6 o'clock.
Yeah, someone back up with that.
No, 6. Wait for Ashley.
You just say a number answer.
She didn't say an answer.
Yeah.
Answer what? B. B is nitrogen and oxygen. D. Is it D? D for donkey?
You can just say my name.
Okay. I didn't say
D for David.
D for David. Is it D for
You don't
David?
need to say a name.
D. The answer is D. Okay, why? Because this will dissolve, this will dissolve, this will dissolve. This will dissolve, this one will not dissolve. Okay? Next. Where? I don't have. It says 5:56 right here.
Yeah, clock is 5 minutes after.
We ask a internet clock. See? Where's the internet clock?
It says 12.
Real time now. 5:56. Hello.
No, it's according to your.
No, it's in this internet clock, right? It's Serangoon right now. SGT, right? 5:56. So don't bluff me, huh?
No.
6:55, yeah.
And what does that mean?
You usually pass my all on that.
I see. You know what I mean? That means you are very hard. Okay, you want to do more. Okay.
Oh, yeah.
35.
I don't want to.
Which one of the following pair? David, last one. David, which one of the following pair can be separated by heating? Oh, I went through this before. I don't know if you remember.
No, I don't remember.
I don't remember. Okay, then we ask Jim. A is correct.
Yeah, that's the idea.
Yeah, it's correct.
You know, like.
Okay, why? Because wait. Ammonium, right? And okay, you guess this way you can go. Yeah, segment. One more time. Because ammonium chloride can this S word.
S word.
Yeah, S word. No.
Sterilize.
No. It's a process.
L.
L. Can what? Ammonium chloride can. A. No. Okay, hangman die.
I. E.
E.
Come on, put something closer on there.
Quick. What? Sally. What? Come on, it's something you know.
Hey.
Ammonium chloride can what?
Salinate.
No.
A.
No. Then.
L. No.
L right here.
I.
Oh no. Then.
I.
Wait. I. What? No. Yeah. What am I
You
supposed
need
to
to
draw?
draw the fire also.
Draw fire. Okay, draw fire.
No, later, that's one.
Yeah. Quick. Come on. Guess the word. Can go. What's the word? T. There. What? Come on, there's a starting word, right? How come you can separate by heating? Because it can something. What? Boston, do you know? Boston don't know. You don't know. Wait, no more? No more, you don't know? Any other guess? Guess around.
Put one more letter.
Yeah, give me that letter.
Just put one more letter for yourself.
You? Who said you? You? You.
Sublimation.
Yeah, sublime.
I haven't done this before. Okay.
Yeah, it's not how she know. How come she knows, right? So
I got the schools.
sublime. Okay, I'm going to try again. Sublime. Yeah, say it by Sarah. Goodbye. See you. Bye.
Thank God next week.
Next week is okay. Bye. Good luck for your test or whatever WA you have. Bye bye. Bye bye. Bye bye. Yeah, help me open the door. Bye, Blossom.
Hi.
Bye.